We're ready to go. All right. I assume we're ready to go.
Let's go ahead.
Oh, sorry, I didn't want to sure so going. All right. Well, good morning or afternoon, depending on your time zone. My name is Peter Srajer. I'm with the CUIIC Academy here. This week we have an amazing presentation. I want to thank you everybody for joining us. This is the 19th Canadian Underground Infrastructure Innovation Center Academy webinar. Today we're going to be doing artificial intelligence approach to design collection for utility surveys, engineering design, and digital twins. This is by Douglas Culbert, the Chief Data Officer for Spatial Data Analytics. Again, thank you, Doug, for this. CUIIC Academy, we're organized by the Canadian Underground Infrastructure Innovation Center. It's a University of Alberta and Benjamin Media Inc. Conglomeration. We offer classes, courses, webinars, and events to help further underground infrastructure educational opportunities. Slide. The CUIIC Academy, we have our webinars every third Thursday of the month. Please join us for our next one, which will be on August 15th. If you want to take a full list of the past and upcoming webinars, please visit our website at cacademy.cuiic.ca. Finally, thank you again to our sponsor, 2024 Webinar Series sponsor, Westlake Pipe and Fittings. Thank you very much for your support on this. So, at this point, I'm going to introduce you to Douglas Culbert and hand it over to him so he can introduce you to himself and start on the surveys or start on the webinar. Off to you, Doug.
Okay. Thank you, Peter. So like Peter mentioned, today we're going to discuss artificial intelligence, using it as an approach for data collection for utility surveys, engineering designs, and those of you who are starting or exploring digital twins. The agenda, I thought I'd give kind of a brief background. So my goal for this discussion is to provide an overview of the industry. So where we started, where we are, and how AI and automation are complementing the field to finish process, and those who are starting or investigating digital twins. So we'll go through a quick overview of who I am and how my career has placed me here today. So what qualifies me to chat. A brief background on the evolution of survey equipment. Then we're going to look at the different approaches or perspectives leadership takes when determining a data collection and processing strategy. And I've typically seen the following. They're either project-based approaches, so solving today's need with established tools and processes, or longer-term strategic investments in tools and processes. These could be triggered by project size increases, scaling your organization, and or maintaining or increasing competitive advantage for those in the private sector. And we'll follow up this with how AI and automation are impacting the field surveying and data collection sector, the associated workflows, and how that may impact or provide some sort of impact to your organization. And following up, I'll conclude with some summary thoughts and open up the chat for questions. So a little bit about myself. I'm a graduate a few years ago from Lakehead University, geology major. This is where I was introduced to GIS and remote sensing. And at the time, the late 90s, Lakehead University and UBC were the only two universities that offered GIS software to undergraduate students. So that's where I got my feet wet. After that, I did a post-degree specialist program at Sault College. It was the second year that was in place, and we studied specializing in GIS and remote sensing. So got the hands-on technical skills. Then later in life, however, having learned a lot of hard lessons in the entrepreneurial space, I applied and got in and finished my executive MBA through Athabasca University. From a career perspective, I had a startup within the first 2 years out of school called Huron Geomatics. We did data collection and GIS and analytics for a variety of different sectors, mostly municipal government, so water, wastewater, and transportation, telecommunications, and small electrical utilities. And as we grew, I had some challenges with, not necessarily challenges with staff, but that they didn't want to be on the road living in hotels for half the year. So that was right around the time of the advent of Google Street View. And so we started exploring that technology. I got into mobile mapping back in 2011. So bought I'll call it half lab rat, half commercial product. It was just the first gen of mobile mapping coming out of Trimble. The following year, we got into unmanned aerial vehicles. So helicopter and fixed wing drones for flying aggregate pits for year-end inventories and doing environmental assessments. Got into 3D stationary scanning on tripods where we supported water and wastewater plants, manhole inspections, vaults. We did some nuclear facility work in railway stations. And like I mentioned, our customers were everything from small municipalities to large urban centers, water, wastewater, roads, telecom, and electrical. And we serviced mostly Ontario, but across Canada as well as into the Caribbean. So I worked on 9 different islands for storm restoration, mergers and acquisitions, asset management, and risk modeling. In 2015, I sold Huron Geomatics to a company called Oakville Enterprises Corporation. They're an energy services company, and they also own an electrical utility. I was in charge of innovation, so I discovered and built new service offerings and technology, and also had the IT group under them, which included cybersecurity, IT, and OT. 2 of those companies have 45% of the utility locating market in Ontario, so heavily involved in helping out infrastructure companies as well as working for a utility myself. In 2021, made the jump back into the entrepreneurial space, and I'm the Chief Data Officer for Spatial Data Analytics. I'm one of the co-founders. I advise and support the R&D and development teams, as well as do solution engineering for data automation. So if we take a little step through where we've come, if you look at the early days of surveying, you had your traditional manual process, your theodolite, your hasting stick or measuring stick, your chains. You could do some manual collection and get a few points per hour, typically noted down on paper. We've transitioned into your total station, your RTK GPS, photo-based, laser-based measurements. That sped things up. So we got digital collection and digital files. We went from a few points per hour to a few hundred points per hour. And today we're seeing a lot of interest in unmanned aerial vehicles, whether that's helicopters, airborne, boats, terrestrial vehicles with laser scanners and cameras on them, or you're into mobile mapping or aerial LiDAR system and cameras. And typically what I look at, doesn't matter what job you're looking at, you're always bringing 2 tools at least 2 tools or more to the job, and that's based on environment. So if you're doing a mobile mapping job, you're driving on the road, but what about the stuff that's rear lot, easements, that kind of thing? So you bring a variety of tools, and that adds a different level of complexity. So when I've talked with customers in the past, or other partners trying to determine what technology or solution to bring to a project, I see kind of 2 different ways of thinking. One is the short term. What is the project we have today, and how do we accomplish it? And then there's a long-term strategic process, and that's like, how are we future-proofing our business? What are the other life cycle requirements in some of our projects? How are we going to grow as an organization? And growth could mean growing bigger or being more efficient. And what is scalability? Are we having challenges with retaining talent, challenges with processing the volumes of data, the requirements of projects? How can we scale up? And you notice both of them have in start their organizational readiness. And a lot of this has to do with change. So looking at who's your established team, what equipment configurations that you already have in place. So whether that be simple data collection dictionaries and lookups, or combinations of equipment to collect your data, what are the hardware and software configurations and setups, licensing, and interdependencies that are in place? If you look at import and export routines and templates, so have you got an established data dictionary in the field that matches standards, whether they're text-based standards or CAD or GIS standards in the office, and you've got a nice set of scripts or routines that bring them into your workflow? What about integration with your various workflows? So into the pre-design, detailed design, high-level design, reporting, defect analysis, that type of thing. And if you've got already scripts built, routines established in your off-the-shelf software and workflows that are dependent on those, adding something new can be quite a disruption. But above all, I would say you've got the trust. So you got the trust established in the process, and there's typically some skepticism of introducing anything new or different. So what a lot of people are looking for is that predictability. Can you use this data? Can you perform calculations? And already you've got established expectations. So that's where some of the challenges are with disrupting your tech. That project-based approach, your team and the training are specific to certain tools and technology. The processing software is already configured, whether you did that in-house or with your vendor, and aligns with your existing field processes. And often there's internal ownership. So your team has built this, they're proud of what they've got put together, and it's already in place. Then you start looking at the exports to the data delivery formats. So those could have been built internally, and the team is proud of what they have in place. And the organization's culture is comfortable with what's already there. So they know how much time it's going to take, your unit rates, what the quality is going to look like. For resource planning, you know how many people you need at different stages in the workflow and things like that. So considerations when you're looking at introducing something new like AI or a different type of technology, essentially it's change management. There's a lot of variables that go through your mind. What are the considerations that need to be addressed? Is it a CapEx or OpEx? Is this new cost or requirements perceived or actual? The new equipment, is it going to require additional training, maybe hiring new talent or buying a whole suite of new tools? How does it work with aligning to established tasks or functions? Do you need to change your existing workflows? So often, like in my past, I've seen somebody adopts an enterprise solution or a new set of technology, and all of a sudden there's a lot of setup and configuration requirements. There's changes in workflows. There might be changes in your HR model because different people need to do different things. It can have quite a disruption. And then looking at it, yeah, does it impact your established rate cards? So your quoting and your job estimating is all disrupted. Your productivity rates, so you got your learning curve and your break even, and then you're reaching a level of performance. How long is that going to take? What does that associated P&L look like? And then what does the resource balance? So if you add in new technology that's more efficient, you've got established ratios of field surveyors, inspectors, CAD technicians, GIS techs, data analysts. How does that change if you've introduced something new? So, but we're already seeing some of these disruptions as new technology become more commonplace. So some of you might be looking at the the pay-as-you-go software and hardware. So the accuracy as a service. You can buy the hardware relatively inexpensively and then subscribe to the level of accuracy you're looking for, or have the software turn on and off as on a unit base or a pay-as-you-go. We're seeing the integration of different technologies that's making things more efficient. I think you had a presentation a month or two ago on the fusion of underground utility locate units and GPS. that's extremely beneficial. That's actually one of the technologies we introduced at OEC was mapping as you go with locating. So they've started working away at that. Drones and other unmanned systems, and that doesn't need to be typical definition is a drone, but you can also have boats and tracked vehicles and things like that to collect spot robot dogs, to collect imagery and or 3D scan data. We did work with a client that had a spot robot going through a nuclear plant and going and taking pictures of a thermal image of a certain bearing because they knew that there was an issue with it and they're waiting for an outage. So they monitored it daily with the robot. You look at 3D scanning and mobile mapping, or even high resolution imagery, whether it's coming from airborne systems, drones, helicopters, fixed wing aircraft, or even the microsatellites, the low orbit satellites that have been released. But the big thing we're seeing with some of these technologies, you can get efficiencies as high as 150 to 1 or greater. So when you start considering these options, this is when the eyebrows go up in the boardroom, because if you're looking at 150 to 1 efficiency ratio, you can't not consider it. So often what we're seeing is there's this misconception that disruptive tech leads to an organizational disruption. But I want to push back on that. I would say if it's approached with the mindset of complementing or augmenting an organization, these disruptions can be easily mitigated. So the focus should be more so on the output and the problem it is solving versus the technology. So just a brief story. I was at a conference 2 months ago, and the vast majority of the attendees were in the satellite imagery market. And the main theme was, how has that market failed? And the real internal discussion was that there's hundreds of millions pumped into the satellite imagery space, but there's very few that are actually focusing on the outcome. So they're selling the tech, they're selling megapixels, they're selling coverage, they're selling tracking, they're not selling deliverables. And so from the smallest startups to the largest incumbents, they were all agreeing that the sector itself is focused on trying to hype the tech and sell the technology. And granted, they are developing amazing tech, but they've lost sight of what they're actually trying to solve. And that's where there's challenges in penetrating some of these markets. They cited a story where a solar panel company came to them when it was looking at trying to figure out market size in a specific community. And they said, we just want to know the square footage of roofs that are south facing. And the sales team wanted to know how many tiles of image they want, resolution, bands, the date they wanted it. So they're selling the actual product, not the solution to the customer. So this is a common problem across all technology. And I would say is the concern with the disruption to an organization is no one's approaching it from the outcome or the how does it help and augment the organization versus disrupting it. So that's where kind of that strategic planning piece comes in. So in addition to solving the needs of the immediate project you have in front of you, are you thinking beyond the first few steps of the project? So you start looking at rising fuel costs, talent shortages, project delays. These are all reasons to look at more comprehensive data collection solutions. So in addition to, you want to consider the next steps in that value chain or project lifecycle. Who can benefit from more data? So in the kind of the images provided there, is there vegetation clearing that's required? Is there some sort of traffic management or roadside safety planning that's part of the project further downstream? What does a job site analysis look like? Is there slopes off the side of the road? Are there other hazards that need to be considered when setting up to do the work? Worker safety. So are they exposed to high volumes of traffic? Are they exposed to falls, working at heights? Those all kinds of things like that, as well as some of the more intangible topics that might not be front of mind when you're doing field surveying is what does organizationally, what do your ESG targets or reporting look like? If you can reduce the trips to the field or process high volumes of data to service the entire project lifecycle, you can reduce that missed data or gaps in the information, reduce those number of trips to the field. Can you quantify those savings in, for example, time and labor, but also what are your greenhouse gas reductions that can feed back into that ESG reporting and other types of initiatives like that. So when you're looking at looking at AI, ML, 3D scanning, some of these more advanced tools, how many projects are comparable in nature will you have that are going forward? Is this something that you can start building workflows for and adopt and integrate into your organization? Do you build or buy? Do you buy equipment or do you outsource it? Is outsourcing a viable option? Is there somebody close that has a technology that has worked with you in the past? Can you bring them in? What is your organization's plan for scalability and growth? Is this to mitigate increasing demand or other constraints your organization is feeling? Those in the private sector, is it to remain competitive? Are you contemplating a digital twin and need to process high volumes of data to build that detailed foundation of the as-built state? So one thing we've started to run into in Ontario, we're seeing a lot of wired broadband construction going on right now. And the simulations from the structural analysis software have standard clearance measurements, things in them. Even if you populate the attachment points on a utility pole, when you put in the sag and tension calculations, they're being calculated mid-span, and that's not the actual as-built state. So it's good to have that highly detailed model in place of there was planned and then there's actual, having that actual state. So then as you start to simulate things in a digital twin, climate change impact, extreme weather events, road widenings, vegetation modeling, different things like that, you actually have what's out there as opposed to a simulated state. And then kind of the last thing, and I keep bringing it up, is that organizational culture. Is the organization ready to embrace or consider something new? And you need to look at not only the direct stakeholders, but I like to call them shapeholders or internal influencers. They can be either innovation champions or they could be innovation killers. How are you addressing each of their needs and making sure they're comfortable with your decision? But knowing that some technologies coupled together, you can achieve as high as 200 to 1 or greater and are you ready to consider that impact? So back to that resource planning, what does this look like from a resource standpoint internally if all of a sudden you have a 200 to 1 time and labor efficiency savings? And so I kind of get in here now, I'm going to talk about the AI or machine learning. I consider it's just another tool in the toolbox. So there is a lot of hype. Even this morning, there is a CBC article discussing the hype surrounding AI and the lack of tangible results. And some recent industry conferences we've been at, there's some stigma starting to get attached to AI. It's following the same hype curve as drones or UAVs did 10 years ago. There's been a lot of overpromising and under-delivering. Personally, I feel this is due to selling the tech or they're selling the art of the possible versus tangible outcomes. So AI and ML are just this new set of tools to consider in the processing of data. They are essentially just this one more tool that you can augment or add to your toolbox. So not unlike the efficiencies that we recognized when GPS became a main part of surveying, robotic total stations, or 3D scanning, AI and ML is going to result in significant changes in operational efficiencies. not unlike the impact that we felt from those other technologies. And today, there's a lot of different forms. You got your computer vision, so that's photo or video processing. You got point convolution, that's more on the 3D scanning side of things. So that's what it is statistical modeling to detect shapes by using statistics. How is one point spatially relative to the next point and the next point and the next point? You look at tabular data pattern recognition. So if you've got thousands or tens of thousands of rows of data, is there a pattern that we're starting to see? You look at acoustic detection, so sound waves, natural language processing. So many of you probably have a talk to text, whether it's you're training it with Alexa or Google Home. I'm hesitant to say the S word because my phone's going to go off here, Siri, but they recognize your voice and do searches for you or commands or populate data accordingly. A lot of these different tools or approaches are used to code and find features. So adding attributes to tables, recognize patterns or trends. Essentially, they're taking out the tedium out of repetitive tasks. So imagine scrolling through a roadway video log of thousands of photos and saying, click, 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 here's potholes. So in the image there, it's like it goes through, you've trained it on a few 2,000 or 3,000 images of what a pothole looks like, and the machine learning goes through and highlights them all. And so now you've got a table of data that says, here's where all our potholes are, and you can bring that into a GIS and you've got the answer for where to focus, or maybe it's which road section has the highest number of potholes or cracks or other issues, and it's a road maintenance asset management solution. So it's things like that, or the other image showing the detection of utility poles. So using point convolution, what's the shape it's detected in the billions of scan points, and it's finding utility poles. Lost my spot here. So you can collect this data with your choice of technology suitable to the environment. So whether that's a drone or a vehicle or a helicopter or aircraft, you collect the data for the use case, upload the data, and automatically process it. We had one client, we do image and point convolution processing. They had reached out asking about acoustic detection. They wanted to apply it in a water treatment plant. So they were wanting to put microphones in different locations of the water treatment plant and listen for the whine or squeal of a failing bearing. And then they could triangulate from the different microphones and over time trend that and say when they had an outage or repairs, they could focus on replacing certain bearings. So that was an application they were considering. So like I mentioned, the AI is emerging in the data collection surveying sector. It's really just being used to rapidly analyze imagery and point clouds into those meaningful results. So generating your typical attribute tables for inspections and other measurements, or CAD drawings for engineering. So in one of our workflows, we're helping out distribution utilities and telecommunications for the wired broadband engineering. And so what they do is they go out and collect the data. They upload the point cloud to a cloud environment. It automatically goes out and classifies those points and then converts those points into features. So your typical points, lines, polygons. We do some, once we have those in place, then we do some some calculations or spatial analysis on those features. We calculate the heights of the poles, we calculate the heights of the conductors of the attachments, the offsets from curbs, we calculate angles, lengths, proximities, adjacencies, all of that information that's used in either directly in the AutoCAD software, in spreadsheets for doing various calculations, clearance measurements, sag and tension, or right into structural analysis software to model and simulate the new designs. And then ultimately, we're exporting to CAD and GIS, aligned to established standards that are provided by the client or the organization. Essentially, that output matches with the exact expectations of that client. So they really don't know that that drawing is coming from a mobile LiDAR unit and run through AI. It matches the exact CAD standards as if they had collected with their traditional means, their RTK or their total station. And so that really eases that disruption or lack of trust when they have something that aligns with their established workflows. Here's a quick example of AI and what it can do. So we've got an original 3D scan. We pull out the vectors, so it automatically detects the wires, the pole, the transformer, the street light, and turns those into vectors. And once they're into those vectors, they can go into established workflows, they can be analyzed and fit into already available applications in our clients' organizations. So there's very little disruption or any disruption to their engineering practices or design review and the other things that they're doing in these projects. So, and it's in a format that they can do engineering. It could go to the utility to help with updating a GIS and help out with asset management, standards compliance. And that's one of the biggest things that we've been pushing on lately or getting asked to do is the clearance measurements built to spec. So is this primary and the transformer the appropriate spacing? Is there enough spacing between the live secondary and the communications cables? So doing that analysis to see if there's any safety hazards before they even start their design. And then they can figure out their make readies and their plans from there. And then from a risk management standpoint, are poles leaning? Are they too close to curb lines? Are they too close to houses? Is there clearance issues for trucks and things going underneath them? All that type of analysis in that one pass. And like I mentioned before, the outputs align exactly with what the customers are used to using. So it's into AutoCAD, it's into ArcGIS. Get a template and export it, line styles, line weights, labeling, layer names, blocks, rotations, everything is set so that there is no additional work to the client, and they can start working with it with their existing staff. And there's no new hardware, software purchases, or additional training required. And kind of one of the other pieces that has come up, which makes sense, is how do we know that the AI captured everything and it is accurate? It's not perfect yet. It probably never will be perfect. You've got pictures and you've got point clouds, but you've got various weather conditions, lighting levels that impact pictures. You've got issues that impact the level of accuracy of the LiDAR. So if you're producing this automated output, how do you know you can trust it to do design and engineering? And so AI is extracting and doing the best it can, but the decisions and those sign-offs are not done by AI, it's your team. So the next step is to give the professionals on your team full access to all the source data, and to get that comprehensive view of the full project area. So this helps with data validation, information gap filling, and confidence that information is correct. So you can bring it up in a viewer similar to Google Street View, but the point cloud is overlaid, as well as bring in the vectors and validate that everything is captured accurately. Look around the project site. Can you put in an anchor? Is there a conflict with a fire hydrant or other piece of infrastructure? And so when you're designing something or wanting to relocate it, what does the project site look like, so that you can make those decisions and feel confident that your design or your plan is going to get approved. The other part, kind of like I mentioned earlier, is what stage are you at in that project lifecycle? Is it preliminary planning? Are you trying to get an understanding of what's out there and what needs to be considered? Are you fusing it with subsurface utility information? So you're doing underground locates, you're pulling in other CAD drawings or other surveys. How can all this work together on that preliminary planning phase? Is there sufficient data that from one collection, one pass, you could incorporate it into a high-level design or even the detailed engineering? So it's looking at those different workflows and how you can incorporate and reprocess the data in one pass to solve many requirements. Kind of in conclusion, that I would say that technology adoption, in this case AI and automation, is yet another change management process. Just like we introduced robotic total stations and GPS a few years ago, some of you have incorporated drones and stationary 3D scanning. This is another tool in the toolbox. So you need to focus on those outcomes and build that trust early, and adding this as just one more tool. It's not a replacement for people. It's not a replacement for your entire organization. It's one more tool to add to the toolbox. So avoid that technology hype and focus on that impact. So how can it fit with existing workflows? Really meet with your customers or all users in that value chain and build that internal trust, that requirements list. It can be combined with new and existing technology and incorporated into one solution. So our one client that's working on about 3,000 kilometers of wired broadband has bathymetric data from boats, mobile LiDAR data, RTK surveys, and image-based, it's called the CUIIC GPS. They take a photo, and it scales the photo, and they can pull their measurements. So they've got 4 different sources of data, but they all have to go into one seamless CAD drawing that matches their standards. And so we've incorporated all these tools based on the environment that they're collecting data in, built that workflow, and it goes into their CAD drawing. Their design team picks it up, and off they go. And that data, like I said, that data automation can be incorporated and accommodate all different levels of technology. So when it comes to that automation standpoint, there is a variety of approaches. So you've got you could raw script it in Python, which our team can do. FME, so that feature manipulation engine by Safe Software, is a drag and drop desktop solution for converting formats and building workflows to normalize and clean up data. Or you have AutoCAD or ArcGIS, where you've got workflow scripts and models that you can build to normalize data and build it into a consistent output. And those outputs, whether they're established CAD standards, standard data formats, CSVs or JSONs, Excel, Esri shapefiles, or a data conversion. You might be looking at pumping this out to other third parties, other departments, incorporating with financial systems, those types of things. So that's where this kind of data automation can reduce a significant amount of time. So kind of concludes my chat today. Feel free to reach out. I'd be glad to discuss this in further detail, or provide examples, or help you out one way or another with any of the questions you might have. Kind of one of my closing remarks, and I'm going to paraphrase Gerald Grant from that CBC article this morning. He's from the Sprott School of Business in Carleton. People are not seeking technology per se. They're seeking outcomes that are beneficial to them and that they're willing to pay for. Whatever hype you have around technology is just hype. If it doesn't deliver something novel or meaningful to support your organization, why pursue it?
Right.
Closing remarks. And we'll welcome Peter back.
Thank you very much, Douglas. Very, very impressive presentation here. It's one of the first I've seen that kind of marries the real world business use and the technology behind AI. So thank you very much for that. It's very interesting.
Thank you.
If there's any questions from the audience, please feel free to put them down in the Q&A box at the bottom there. And until we get those, I got a couple of questions on my own just to get this started off. You kind of mentioned on the the challenges of overcoming the hype of and the client expectations. Any comments on how to get through that?
I would say that the biggest thing is, what is the challenge you're trying to solve? So it goes back to I love to listen to Simon Sinek's discussions and the why, how, and what. So why are you doing this? And then figure out the how, and then what's the outcome. So what is the actual thing you're trying to solve? And I'm an advocate of pencil and paper if that's the solution. But if there's another way to do it, like our one client came to us 2 years ago and said, normally we bid on, the biggest job we've ever bid on was 30 kilometers. And we just won a project that's 3,000 kilometers. And it's due in 2 years. How can we possibly get this done? Because it's either A, we look at this, or B, I have to find 250 plus field surveyors, buy all the hardware, buy the vehicles, put them up in hotels, and I still don't know if we can get it done in the time frame that we're supposed to get it done. And we know we're going to miss information. And throughout the past 2 years, there's been changes in scope, changes in requirements. And because they used a combination of, like I mentioned, boat, drone, RTK, GPS, and mobile mapping, they have it covered that they can go back and reprocess the same data. And this project is anywhere from 12 to 20 hours from their office. So to send somebody to the field to pick up something missed is not plausible. But the change management piece, there had to be trust. And so they benchmarked, when they ran the mobile LiDAR, they ran it through a community and benchmarked it against a survey they had already done, and found that it was actually more accurate than the survey they completed. So everyone said, yes, let's go.
Excellent. All right, thank you. Very interesting. Question from the audience here. What is a standard efficiency ratio? So I guess, so I can sense the significance of 150 or 200 to 1.
That number came from one of our clients. So they're looking at a traditional survey with an RTK GPS, surveying a topo and utility pole profile information. They can do about 1 kilometer per day. Whereas with a mobile LiDAR unit, they were driving both sides of the road, obeying speed limits, making sure they're following best practices, and they're doing 150 kilometers, centerline kilometers, but getting both sides of the road per day.
Excellent. Yeah. Very interesting. That makes a lot of sense. Second question here. The extraction of information from pole images is quite interesting. Can you please provide more information on how this is achieved? Transformation of images to vectors and extracting features from the vectors themselves.
Okay. Yeah. In that particular example that I showed, that was a clip from a mobile LiDAR unit. And so we've built AI detection models and algorithms that scan through the entire data set and find poles and wires. And then once we've isolated them and classified that point cloud, we have other algorithms that go through, once a point cloud's classified, to say, draw me the conductors, draw me the pole. And once we have those vectors, then it's, I call it geomatics engineering. It's just Z minus Z. So we know the top of the pole, we know the bottom of the pole. Top elevation minus bottom is what's out of the ground. And then your typical 10 plus 2, we know the actual height of the pole, and then we know our conductors, we know what the transformer is, and all of that ends up being, for a pole profile drawing, it sounds kind of simplified, but all those measurements go into a CSV file. And then we've got code that writes it. So one of the inputs, the code reads a CAD standard from the client. So the blocks, the labeling, the font styles, and we just put in the measurements and it draws the CAD drawing for them.
Very interesting. Yeah, I can see that being an extremely valuable piece of information. I mean, I come from years of field engineering use, and I think the ability to limit the exposure in the field anybody is, a prime consideration for, a lot of clients, because of, safety and everything else. It's similar on to that line there. Do you find it's easier to, I guess, push the client this is a safer way of doing things or a more cost-effective way of doing things?
It's both. So there's the cost side of things, but in particular, it was a safety thing. A lot of this work was in the first project we did, the customer that I mentioned. We've done projects in a variety of environments, but this 3,000 kilometers was in Northern Ontario. So you're dealing with bush, swamps, or rock cuts. And so major issues from a slips, trips, and falls standpoint. If they fell in a swamp, there could be a drowning. You're isolated. You're tens or hundreds of kilometers away from healthcare. And in efficiency standpoint, certain areas you only have a limited amount of time to collect that data, and then winter sets in. So your productivity, if you're going to do it a traditional way, just drops because you have to take a shovel, dig your way to the pole base to pull your measurement. If you can drive past a few thousand poles in a couple weeks, you take that data extraction and now move it to the office. And coupling that with the viewer, you can not only look at the extracted data, but if you have to clean anything up, you can just see it right from your desktop. And it aligns with that work from home perspective. So it's easier to survey a pole sitting in your chair in the office than it is fighting bears in the north.
Yeah, it certainly is. Absolutely correct.
Yeah.
All right. Thank you, Doug. I don't see any more questions coming through. So thank you very much again, Doug, for the presentation. I find it a fascinating kind of a juxtaposition of, like I said, AI with the geospatial. I mean, the hype is still there with AI, like you said, and it's nice to see it married in practical terms, because we see a lot of tools and techniques come and go, but the ability to push those two together for efficiency and safety is something that's going to be critical for us in the industry. So again, thank you very much for the presentation. I'd also like to thank all of our CUIIC members listed on the board there on the screen. And as well, again, our next webinar is the third Thursday of August. And I invite everybody to come to our website, register for it, and see where things are. And as well, again, thank you again, Doug. I appreciate you
welcome.
coming here. And I guess with that, we'll end our presentation. So thank you.
Okay. Thank you very much. Have a great day, everyone.